Good. Ready? Here, read about this. Ready? Come on, let's go.
Terminal speed. In actual practice, falling objects do not continue to accelerate at 9.8 meters per second squared. As they fall, their failure to continue gaining speed at the same rate is caused by the upward force of air resistance. The acceleration of the object depends upon the net force acting on the object. If you knew the numerical values needed, how will you calculate the net force exerted on the ball shown in the figure?
Okay, so what do you need to do to calculate the net force? What do you do?
Subtract the air resistance from the object's weight.
Right? Okay, so the air resistance, right, is an upward force, right?
Right.
And gravity is a downward force, right?
Right.
And so in this picture, the golf ball, right, and the weight is the downward force.
Right.
Upward force is air resistance, right? Okay, so let's see how this extends. Go ahead. As
downward speed increases, so does air resistance.
Thus,
there comes a time when air resistance equals the weight of the object. At this speed, the object no longer accelerates, but instead it continues at the same speed. This follows from A equals F.
force.
A equals acceleration.
Net force. No. Acceleration equals net force divided by mass. Yeah.
Since if the net force is 0, the acceleration also must be 0. The final speed attained is called the object's terminal speed. Consider a falling rock at a time when it is traveling at just less than a terminal speed. Will its acceleration be less than equal to or speed? Well, its acceleration will be less than equal to or more than 9.8 meters per second at this time.
Well, it says when a rock at a time when it's traveling at just less than terminal speed. That means it hasn't hit terminal speed. That means it's still accelerating at what?
9.8 meters per second.
Go ahead and write underline equal, right? Because it hasn't hit terminal speed, right?
Right.
So stop fidgeting around, all right, please?
Yeah.
So underline just less than terminal speed. So and then write before, right? BEFORE, and then underline equal. Okay. Go ahead. So underline just less than. Good. Now write before. Right on top of terminal, right before. BEFORE. Right? That means before the rock reaches terminal speed, it's traveling at 9.8 meters per second squared, right? So write equal. And then let's see if we got it right, okay? You agree?
I agree.
Okay. Oh, less.
Yes.
When the object finally reaches terminal... Okay, read. I got it wrong. So write less than. So write less. So don't... so write less than. Erase that. And then underline less than.
How am I going to erase?
Just underline less than.
Less.
Circle less than. Circle it. Right?
Yeah.
Okay, now let's read here.
Answer equals less. When the object finally reaches terminal speed, the air resistance is equal to the rock's weight at slightly less than the terminal speed. Air resistance may be considerable, but less than the rock's weight. The net force on the rock is its weight minus air resistance. Since air resistance is less than the rock's weight, the acceleration must be less than the acceleration of gravity.
What's this? Oh, its acceleration be less than, right?
Mm-hmm.
Equal to. Don't switch. Equal to or more than 9.8. Its acceleration. Oh, at terminal it's equal. But the rock's acceleration. Okay, so read the question again. We'll read the answer. Go ahead.
Consider a falling rock at a time when it's traveling at just less than terminal speed. Will its acceleration be less than equal to or more than 9.8 meters per second squared at this time?
Okay. Now let's just try it one more time.
Answer equals less. When the object has finally reached terminal speed, the air resistance is equal to the rock's weight at slightly less than terminal speed. Air resistance may be considerable, but it is less than the rock's weight. The net force on the rocks is its weight minus air resistance. Since air resistance is less than the rock's weight, the acceleration must be less than the acceleration of gravity.
Do you understand it or no? Don't say you do if you don't. Okay. So when it reaches terminal speed, air resistance is equal to the rock's weight. Okay?
Okay.
But it's before. Say, first of all, you don't understand.
I understand.
Okay. So do you agree that when the rock's weight equals air resistance, right? Look,
Right.
Then it doesn't accelerate, right?
Right.
Right? If there was more air resistance, it would slow it down, right?
Mm-hmm.
And then push it back up after a certain amount of time, right?
Right.
If it didn't build up the speed, right?
Right.
But it doesn't. So the weight of the rock or a golf ball, right, weighs more than air resistance, right?
Right.
And at the point when air resistance is equal, that's called terminal velocity, right?
Right.
So the weight of the object equals the air resistance at terminal velocity, okay?
Mm-hmm.
So write weight of object. Weight equals. So write IE like this. IE. Weight equals air resistance at terminal velocity. Weight, W E I G H T.
Weight
Equals AR, air resistance. Just write AR.
air resistance.
At terminal speed. At AT. Terminal. MI. N-A-L. Speed. S. Do you know how to spell speed?
Yes. S-E.
Stop sagging it. P. P. No, not seed. Speed. And not sapede.
Wait.
S-P-E-E-D. P-E-E-D. D. Speed. Period. Okay. Cool. You did it. Good job. So tomorrow, what will we work on?
Circular motion.
Yeah. Circle, right?
Yeah.
Good job. Kiss. Kiss. Thanks. Hey, Abby, you want more iced tea?
No.
Here.
I don't.
Have it. You want it? Abby, you want some iced tea? Abby, want some iced tea?
No.
Why? Come on, just drink some.